Welcome to our lesson. Our lesson for today is about loss of exponents. But first, let us define what is exponent. When we say exponent, an exponent refers to the number of times a number is multiplied by itself. For example, 2 raised to 3 written like this. This is an example of exponent. We have 2 raised to 3. 3 is called the exponent index or power, while 2 is called the base. And 2 cubed means 2 times 2 times 2 is equal to 8. What are the laws of exponents? Number 1. Multiplying powers with the same base. In multiplication of exponents, if the bases are same, then we need to add the exponents. Example. 2 squared times 2 cubed is equal to what? How are we going to solve this? We can solve this by applying law number 1. As you can see, the operation is multiplication and it has the same bases. So we only need to keep the base, which is 2, add the exponents 2 plus 3, simplify it, and we will have 2 raised to 5. Another example. Notice the operation is multiplication and they have the same bases. 2 over 3 raised to 2 times 2 over 3 raised to 4. Keep the base 2 over 3, add the exponents 2 plus 4, and we will get 2 over 3 raised to 6. Another example, negative 3 raised to 12 times negative 3 raised to 2. Notice they have the same bases and the operation is multiplication. Simply keep the base negative 3, add the exponents 12 plus 2, and we will get negative 3 raised to positive 14. Number 2. Dividing powers with the same base. In division, if the bases are same, then we need to subtract the exponents. Example. 2 raised to 4 divided by 2 raised to 3. It can also be written as 2 raised to 4 over 2 raised to 3. Notice that the operation is division and the bases are the same. So simply copy the base, which is 2, subtract the exponents 4 minus 3, simplify it, and we will get 2 raised to 1. Remember, any number raised to 1 is equal to itself. So 2 raised to 1 is equal to 2. Another example, 9 raised to 10 divided by 9 raised to 13. Can also be written as 9 raised to 10 over 9 raised to 13. Simply copy the base since it has the same bases. Subtract the exponents 10 minus 13 and we will get 9 raised to negative 3. Another example. Negative 7 raised to 10 divided by negative 7 raised to 3. We can also write this as negative 7 raised to 10 over negative 7 raised to 3. The operation is division and it has the same bases, so simply copy the base, which is negative 7, subtract the exponents 10 minus 3, and we will get negative 7 raised to 7. Number 3, power of a power. In power of a power, you need to multiply the powers. Example, 2 raised to 3 raised to 4. How are we going to solve it? We will apply the law number 3. So simply copy the base, which is 2, multiply the powers, 4 times 3, then simplify it, and we will get 2 raised to 12. Another example, negative 4 raised to 2 raised to negative 3. Simply copy the base, which is negative 4, then multiply the powers, 2 times negative 3, simplify it, and we will get negative 4 raised to negative 6. Another example, 5m raised to 4. Simply copy the base, which is 5, multiply the powers, m times 4, simplify it, and we will get 5 raised to 4m. Number 4, multiplying powers with the same exponents. Here, the powers are same and the bases are different. We multiply the different bases and copy same powers. Another example, negative 2 cubed times 5 cubed. As you can see, negative 2 and 5 are different bases. So multiply them, then copy the same power. So we will get negative 10 raised to 3. Example, 5 raised to 3 times a raised to 3. Multiply the different bases, which is 5 times a, then copy same powers, simplify it, and we will get quantity 5a raised to 3. Number 5, negative exponents. If the exponent is negative, we need to change it into positive exponent by writing the same in the denominator and 1 in the numerator. Let us cite an example. 9 raised to negative 3. As you can see, the exponent in this example is negative. So how are we going to solve this? So first, we will write it as a fraction. We will write 1 as our numerator. Then, write the given into the denominator, but after putting or writing it down in the numerator, the exponent of the given will change. That's why the denominator has 9 raised to 3. Then, simplify it, it is equal to 1 over 729. Another example, negative 2 raised to negative 4, another negative exponent. We will write it into a fraction. Write 1 as your numerator, then write the given as your denominator, but change the sign. So it will become negative 2 raised to 4. Then simplify 1 over negative 2 raised to 4. Then it is equal to 1 over 16. Another example, we have 1 over 3 raised to negative 4. Notice in this example, we have a fraction, and the negative exponent is written on the denominator. So we will just get the reciprocal of this one. But after getting the reciprocal of this one, change the sign of the negative exponent. So we will have 3 raised to 4. Remember, all whole new number, the denominator is considered 1, so no need for us to write 1 as the denominator. So 3 raised to 4, simplify it, it is equal to 81. Another example, quantity 3 over 5 raised to negative 3. So in this example, we will just get the reciprocal of 3/5. And the reciprocal of 3/5 is 5/3. Then change the sign of the exponent so it will become positive 3. Another example, negative 3 over 5 raised to negative 2. So, same process, we will just get the reciprocal of negative 3 over 5, then change the sign of the exponent. So, we will have negative 5/3 raised to 2. Number 6. Power with exponent 0. If the exponent is 0, then you get the result 1 whatever the base is. Example, 1/3 raised to 4 times 1/3 raised to negative 4, then that is equal to 1/3 raised to 0. The base is 1/3 and the exponent is 0. And we will get 1 because any number raised to 0 is equal to 1. Another example, 5/3 divided by 5/3 is equal to 5 raised to 0. Any number raised to 0 is equal to 1, so 5 raised to 0 is equal to 1. Another example, bx times b raised to negative x is equal to, copy the base b, add the exponent, and the result is 0. B raised to 0 is equal to 1. Another example, 2 over 7 raised to 0, any number raised to 0 is equal to 1. Negative 9 over 5 raised to 0 is equal to 1. Negative 11 raised to 0 is equal to 1.